Hi everyone. So good evening. So finally we are live here and one of the most awaiting season. I think many of you might be waiting for this season. So finally we are here and now the thing will be what is my plan for next you can say 10 days so that we can summarize entire probability and statistics for machine learning as well as for data science. Okay, so this course will be for all the branch of engineering. It is not going to be restricted to data science and AI only, right? So what is my plan here is I'm going to make the priority I'm going to teach priority from very basic and then to advanced level, right? So people who are preparing for any sort of examination, right? Any sort of examination, they can also follow this course, right? So hi Atif and Asdeep, good evening to all. And please confirm once my wife, my voice is okay or not, right? So that we can quickly begin the session. Yeah. So I hope everyone is excited here and everybody wants to know that how Dheeraj sir is going to deal with the probability, right? So guys, I'm going to put my entire experience of learning probability, okay, from different source of learning. Okay. I will be disclosing my source of learning as well as we move ahead. Okay. So yes. Fine. So this is going to be a first session where I will be starting with the probability, and once the probability and statistics will be over, I will be telling you my source of learning. Okay, from where I learned and I made this entire topic quite simple, right? So yeah. Yes, Pooja. So good evening. Good evening. So please help me with your attendance, guys. You can hit the like button as well as you guys can also share wherever it is possible, right? So people can join us, right? Fine. So this will be the very first session on probability and statistics, right? So I'm gonna start with the probability, right, and statistics, right? So already we have done, you know, we have done the basics on this probability and statistics. That was, permutation and combinations, right? So we will not directly talk about what is probability and what is statistics here. I'm going to just talk about some of the very important fundamental concepts, and I will also tell you what are the prerequisites you need to before you start learning probability theory, right? So the basic mathematics which is required, okay, to understand the entire probability is very important. So I will talk about them, right? So yeah. So the very first thing that I'm going to talk about, okay, before I start the probability theory here. So the very first topic that we have to understand is very first terminology, that is going to be a random experiment, right? So what is this random experiment? Okay, what is this random experiment? Okay, and what is this probability, right? That we have to understand. So probability. Okay. So let me take one very basic example, guys. Suppose I'm conducting my session right now, right? So you might say that you might be having some initial belief, right? Okay, that yeah, Dheeraj sir is going to teach well, right? But there is some belief you can say, okay. So if you're going to find the probability of that the Dheeraj sir lecture is going to be amazing and he's going to finish everything, right? Okay. So you can say that you are just finding the probability of that, right? Okay, you're not sure that Dheeraj sir is going to do well or not, right? So initial belief is going to be the probability here. Okay, initial belief. So always keep in mind the probability is nothing but an initial belief, you can say. Something is going to happen in your life. Okay, suppose you're preparing for the gate examination. So there are two things that can happen in your life. The first thing is what you might get success or you might get failure, right? So there are what you might get success, you might get failure, right? So I will introduce all the terminologies, okay, but you know your preparation is just like a random experiment only, right? Suppose India has to, India versus Pakistan match is going on, right? So who is going to bat first, who is going to bowl first, okay, what is going to happen? So before that you always do some sort of a random experiment, right? Okay, so random experiment you do, okay, and then what will happen, what are the important conditions when you can say that this experiment is a random experiment. See, there are various kind of experiment going on, but we can't say directly that okay, all the experiments are random experiments. Okay, so can somebody tell me in the chat box what are those conditions when we can say that yes, this is going to be a random experiment? Yes, anyone please answer. What are those experiment, like what are those conditions which the any experiment should satisfy so that we can say random experiment? Okay, so keep in mind this, if you're going to find the probability of something is going to happen, right? Okay, that will be our initial belief, right? Okay, so remember this, probability of something, probability of something, you can say. And what is this something that we will talk about, okay, as we move ahead? Right now I'm talking about random experiment, okay, but for what I'm going to find the probability? So this inside this argument, okay, the important terminology will be there, that we call it event, right? That we call it event. Okay, so we mostly find the probability of event. Okay, we never find the probability of any random experiment or something. We find the probability of some event, okay, that has to happen. So what is the difference between what is this event, what is this random experiment, and so on and so forth? Okay, so we have to understand. So this is going to be our belief, initial belief. So you can say that probability of getting success is your initial belief, right? Okay, keep in mind, probability is what, guys? Probability is just the initial belief, based on the initial belief that yeah, something is going to happen. Suppose you are in rainy days, right? Okay, so if you think that what is the probability that rain is going to happen, so that is your initial belief. Yes, if rainy days is there, certainly rain will happen. Okay, that you have to keep in mind, right? So what is this random experiment? So there are the experiment, remember, I'm just giving you the two important condition. Outcome cannot be predicted with certainty. Yes, certainly the experiment should have some sort of a uncertainty should be there, right? I mean, the outcome should be non-predictable, right? You can say, suppose you're tossing a coin, you can't say that directly, okay, head will occur, right? If you're tossing a coin, if that coin is a fair coin, you can say that coin does not have anything like one-sided coin. Suppose coin is there, right? Both sided head is there, right? So if you're going to toss it, so certainly you will get head. Okay, so that kind of outcome means what? That is predictable outcome, right? So there is no probability at all, right? You can say, you don't have to find the probability, right? Okay, so probability will be what? Probability will be basically the random experiment. You have to see which experiment is known as random experiment, where the outcomes are non-predictable, right? So the very first condition that you have to remember is what? The very first condition that I'm telling you, this is very important, right? So these are the following conditions that any random experiment should satisfy. Okay, so it should have more than one outcome. First of all, more than one outcome. This is very important, more than one outcome. Okay, if you are tossing a coin, so there are two outcomes. Okay, if you're tossing a coin, there are two outcomes. Understand? If you're suppose one outcome is only there, so that is not the random experiment, guys, right? So any experiment should contain more than two outcomes at least. Okay, it can be two, it can be three, it can be four, whatever, right? And the second point is what? All the outcomes are non-predictable. You can say outcomes are non-predictable, right? Okay, this is very, very important to keep in mind. So this is the criteria, any experiment should satisfy. Okay, so you have got bunch of experiments going on, right? Okay, so whether that is going to be a random experiment or not, right? In fact, see, you are preparing for GATE, you are doing any sort of experiment. So there are two things that you have to always keep in mind, right? There are two things that you have to keep in mind. Understood? So one is what? One is going to be that you have to always remember, right? So one is going to be what? One is going to be a success, one is going to be a failure, right? Please remember this. So this is first point that you have to remember, fine? So after random experiment, if I'm going to collect these experiments, okay, and we are going to put in the set, you can say, right? I hope everybody might have studied about set theory. I will teach you set theory as well, because that is the basic mathematics which everyone should know. In fact, this course is expected, right? I expect everybody should know what is the set, okay, what is the meaning of set, okay, and how many types of sets are there, okay, what are the set representation, okay, how do we represent sets, okay, and so on and so forth, right? So guys, you can talk about various kind of experiment. You can say that if you have one coin, okay, you can toss a coin. Tossing a coin is going to be a random experiment, right? You can throw a die, right? So that is also, that should be a fair die, right? You can also throw any tetrahedral die, okay? So what are the outcome that if you throw the die, what are the outcome you're going to get, right? That will be known as what? Sample space, right? Okay. So today you are going to come to know that sample space will be of two kinds, right? One will be the discrete sample space and one will be the continuous sample space. I think many of you might be only familiar with the discrete sample space, right? लेकिन यहाँ पर सब कुछ आपको पता चलने वाला है. एग्जाम्पल में आप बहुत सारे एग्जाम्पल रैंडम एक्सपेरिमेंट के दे सकते हैं. So can somebody tell me what are the examples of sample space? Sorry, not sample space, random experiment. Yes, what are the example of random experiment? Okay. Some new example you guys can give me. Everybody knows that what? Tossing a coin, right, is kind of an experiment only, because yes, if you toss a coin, there will be two outcomes, head and tail, right? Head and tail. Understood? Yes, guys. Other experiment you guys can tell me. Yes, throwing a dice, right? So you will get 1 2 3 4 5 6. If that is a tetrahedral die, 1 2 3 4 only you will get, right? So in this manner you can decide. That yes. Understood? So can somebody tell me what are other random experiments from the real life? You can tell me from the real life. Yes. If you know, you guys can tell. Yes. Some other experiment of the some other examples of the random experiment. So guys, now I'm going to tell here, right? So these are the important, okay, tossing a coin, you can say, and then throwing a dice. These dice can be, like standard dice that we talk about, like they have 6 outcomes, okay, or tetrahedral die, right? So all those things you have to understand. Now the next concept which comes into picture is, after this random experiment, if any experiment satisfy 2 conditions, then only we can say that is random experiment. Next is the sample space. Next is going to be a sample space, guys. Sample space. Okay. To understand the sample space, okay, you should have the knowledge about set. But it's okay if you don't have knowledge about set. I'm going to cover everything, right? Okay, that is very important. So what is this sample space, guys? What is this sample space? Can somebody tell me what is the meaning of sample space? The collection of all possible outcomes are known as sample space, right? Collection of all possible outcomes are known as sample space, right? That you have to understand. You can say that it is nothing but, basically we denote this sample space by S, capital S, you can say, is going to be it is a set of all possible outcomes, all possible outcomes of an experiment, okay. So it is set of all possible, like if you're tossing a coin, so there are 2 outcomes, head and tail, right? So you will put head and tail inside the braces, okay, inside the curly bracket, and separated by the commas, right? So that is one set representation, you can say, right? That is called, there are 2 set representation. There are you can say one is set builder form and one is what? Roster form, right? So we are just going to put what? 2 outcomes separated by commas, right? Okay, so these are the outcomes which are also countable outcomes, right? You can count these outcomes. Head is there, tail is there, right? Okay, so these sample space are what? These sample space are basically discrete sample space. Example of discrete sample space. Okay, so I'm just going to give this. Okay, so can somebody give me the example? So you can say yes. Suppose coin flip. Okay, if you're going to flip a coin, right? If you're going to flip a coin, so what are the sample space, guys? Sample space is going to be what? The outcome is head and tail, right? This is simple representation, you can say. Okay, but I'm not going to refer this kind of sample space, guys. This is the sample space representation. Okay, okay, what everybody knows. Okay, but what we have to follow will be different. Okay, please keep in mind, right? So this, if you are going to flip a coin or toss a coin, so you are going to get two outcome, that is head and tail, right? Can somebody tell me next? Suppose you are going to flip two coins. Two coins flip. Okay, if you are going to, flip two coins, what will happen? So here, what you are going to get here is you will get head, head, okay, and then you can say that head, tail, then tail, head, and then tail, tail, right? So how many outcomes you're getting, guys? If you're going to toss two coins, there are four outcomes, right? Okay, four outcomes. In first toss, you got head. In the second toss, also you got head, right? In first toss, you got head. In second toss, you got tail. In first toss, you got tail. In second toss, you got head. Or in both toss, you got tail, tail, right? These are the possibilities, right? So, it is little hard, okay? Like there are two coins, okay, and you are going to toss it. So you can simply write, you can simply tell that, yes, these are the outcomes. But as number of coins increases, guys, as number of coins increases, okay, and you're going to toss, suppose three coins. So how many outcomes is going to be inside the set? How many elements are going to be inside the set? Okay. So guys, remember, this is nothing but a single element. Okay, remember, inside this set, this is going to be a single element. Okay, single. Okay, this is single. These are the single elements. Okay, okay, keep this in mind. This is very important to keep in mind, right? So suppose we are rolling, this is first example, second example, third example you can give is, suppose we are rolling six face, you can say six-sided die, six-sided die, right? If you're throwing six-sided die, okay, or you can throw you can say a tetrahedral die, okay, so what will happen? There are four outcomes, but in six-sided die there will be six outcomes, right? Six outcomes. So these are nothing but what? 1, 2, 3, 4, 5, 6. So sample space is this, right? What we are doing here is all the outcomes are separated by commas and putting inside the bracket. Okay, so as far as this is a discrete sample space, remember guys, as far as the outcomes are discrete, right? If any random experiment you are conducting and the outcomes are discrete outcomes, right? What is the meaning of discrete? Discrete means countable, you can say, right? You are able to count. Okay, you're able to count. Understood? So that if you're going to put those countable outcomes, okay, inside the curly bracket separated by commas, that kind of sample space is known as discrete sample space. क्या बोलते हैं उसको? Discrete sample space, guys. ठीक है? So what we are listing here is the example of discrete sample space. Okay, remember, there are two sort of sample space. One is discrete sample space, one is continuous sample space. Understood? So I will give you the tool, okay, to draw the sample space, right? One tool is very important tool that we call it, I will tell you, just wait and watch, right? If you have a patience, you should wait, right? Fine. So can somebody give me other examples? So I will give you the other examples as well. So there are two sort of sample space, remember, sample space. One is you can say that discrete sample space. Many people do not know about this, okay? And one is continuous sample space. Sample space, right? Okay. This continuous sample space will be very helpful when we will talk about random variable, right? So don't worry about what is the meaning of random variable at this moment, okay? Because nothing is going to be random, guys, okay? Since we are doing mathematics, the name is random, but the job done by random variable will not be random, guys, okay? The random is just a misnomer, you can say, right? One of the lecture I was watching, and the professor says that entire theory we are dealing mathematically, right? Okay, the random variable theory, okay, but people call it random. Okay, so that name is wrong. sometimes, you know, if you suppose my name is Dheeraj, okay, if I don't have the patience, means my name is wrong name, right? Okay, so if my name is Dheeraj, means I should have a lot of patience, and I have a lot of patience, means my name is correct. Fine. If you don't accept, it's fine, right? So sample space means there are two sort of sample space. One is discrete, one is continuous sample space. I think everybody knows this. Okay. Those who doesn't know, it's fine. Okay. So this is very important to keep in mind, guys. Understood? So let me talk about discrete sample space first. Okay. Then I will talk about continuous sample space. So discrete sample space, right? Or we can say that simple sample space only, and write down the definition here. Already I have given you the definition. Sample space is nothing but what? Sample space is nothing but the collection of all possible outcomes, right? You can say it describes about all possible outcomes. Describes about all possible outcomes, and one more thing you can say, new definition you can say. Okay. It describes the belief, okay, belief about likelihood, okay, likelihood of the outcome. This is very important. Okay, what does sample space does? Remember, what does sample space do? It describes about the belief, a belief that, yeah, beliefs of likelihood of the outcome. Okay, like head is going to occur, that is kind of a belief. Okay, understood? So likelihood of outcome, like belief of the likelihood of the outcome, right? So describes the beliefs about likelihood of the outcome. This is very important definition, right? And you can say that it describes about the all possible outcomes also, right? Okay, if outcomes are certain, right, likelihood of the outcome means what? There is uncertainty involved, right? Any outcome is going to occur, but there is a uncertainty involved, right? So if something is uncertain, the probability is gonna be good, right? I mean, we can talk about probability, okay? But if something is certain, means life is what? Okay, so that you have to always keep in mind. Understand? Fine. So let me talk about sample space here, right? So suppose you know, basically what we do is we denote the sample space with the set with the help of set here. If I consider this is a set, you can say, I think many of you might be familiar with this notation, or you can say this is a set using some Venn diagram. Okay, you can say this is going to be a set. Okay, this is going to be a set, and there are some outcomes, you can say, right? One outcome is this, second outcome is this, third outcome, fourth outcome, five. Okay, all possible outcomes are there, right? Okay. Make sure that these all outcomes are at right point. You can say, suppose this outcome is here, so this outcome should not be here. Okay, on top of that, okay, you have to maintain what? You have to maintain the right granularity. Okay, that word is there, I will talk about that. Okay, so any sample space, okay, any sample, this is sample space. Okay, we are representing this sample space with the help of set. You can say this is S or gamma, you know, big omega, you can say, right? And so this set should be what? There are some points that you have to remember always. Okay, these are the property, you can say, right? These are the property a sample space should follow. Okay, what are those properties of the sample space? Okay, what is that? First is it should be mutually exclusive. Okay, mutually exclusive and collectively exhaustive. Okay, collectively exhaustive means all possible outcome we have to consider. Okay, all the possible outcomes, and it should be at the right. Okay, this word is important for data science and people. Okay, granularity, right, means this point is here, right? So you know, they should be always at right, you can say, kind of at right position. Okay, it should not be like this is there and this is there and they are on top of each other, so we are not able to, you know, distinguish them. Okay, like we are not able to find the difference between two outcomes. Okay, both outcomes look similar only. Okay, that is what you have to keep in mind. Okay, so these are the properties of sample space. Understood? So sample space means all the outcomes should be what, this, you know, like this should be mutually exclusive, right? Okay, mutually exclusive. Okay, suppose this outcome has to happen, this outcome has to happen, so they are mutually exclusive, right? That is very important to keep in mind. Okay, so suppose tossing a coin, as I took one example. So this is the sample space, you can say, and there is a point H and there is a point T. It follows all these property, you can say, right? And if I'm going to take, suppose this is a sample space, 1 2 3 4 5 6, 1 2 3 4 5 6, right? Understood? So this is the way we can represent sample space, okay, using Venn diagram, using set, okay, like curly bracket and so on and so forth. Okay, and all the outcome we can represent. Understand? So I hope this makes sense to all, right? So let us take some more example, guys. Okay, and this example is going to be for discrete discrete sample space. Discrete sample space. Why we call it discrete sample space? Discrete sample space is nothing but discrete, or you can say finite. Finite. Okay, so we can talk about anything, right? You can say the example of two tetrahedral die. Okay, you're going to throw two tetrahedral die. Two tetrahedral die means what? The die has got only four outcomes, 1 2 3 4. Okay, so in first throw you can say that, in first throw you can say this is the first throw, you can say this is the first roll. Okay, first roll, x is equal to first roll, you can say, right? Okay, I'm just giving it the name. You can say x is equal to first roll. Okay, in future this x will be known as random variable, but for now don't worry about random variable. Just say I'm going to throw in first go, right? So this is the first roll, so you're going to get some 1 2 3 4 5, right? And then you can say this is going to be by, which is the second roll, right? So four outcomes, four outcomes. So how many outcomes total? How many outcomes? This is 1 2 3 4. Okay, I hope this makes sense, guys, right? 1 2 3 4. Okay, so 4 into 4, how many outcomes you will get if you're going to throw tetrahedral die, right? I'm pretty sure that you guys are only familiar with standard die, right? I mean, which has six you know, favorable outcomes. Six outcomes are there, right? Total outcomes. So if you're going to roll two die, okay, two dice, then how many possible outcomes will be there? There will be 36, right? So those things I'm going to talk very soon. Okay, don't worry. I will give you the trick. Okay, I will give you the kind of method. Okay, while constructing the sample space, right? Just I'm giving you some example. Okay. Now you see, suppose someone is going to ask you, what are those outcomes? You can say 1 1. Right, this is going to be 1 1, right? And 1 and 1 we are taking. This is going to be what? 1 and 2, 1 and 3, 1 and 4. And this is going to be what? 2 and 1, right? 2 and 1, right? Like this. This is 2 2. This is 3 3, and this is 4 4, right? So diagonal you can always write directly. So this is the way we can construct the sample space. But guys, this is very difficult. Okay, see, as number of dice increases, as number of coins increases, right, the number of outcome is going to be larger and larger and larger, right? So that is where people feel a lot of difficulty. Oh my god, okay, oh my god, what is going to happen now? So one of the very important tool that I'm going to introduce here is, okay, suppose you have got very big problem in your life, right? Very big problem, right? The problem is, you can say, preparing for the gate examination, and the syllabus is like there are you know, 7 subjects in data science and AI, in, or you can say in other branch, right? So what you're going to do, you're going to divide, okay, you're going to divide your preparation into different phases. The phase 1 you're going to take 2 subjects, phase 2 you're going to take some subject, and phase 3, right? So in this manner you can conquer the world, right? You can win the game, right? So what you're going to do here is you are going to divide your entire experiment. Okay, after all, you know, rolling a die is a random experiment, right? Okay, and whatever outcomes you're going to get, you are just collecting them. Okay, that is called the sample space, right? So what we are going to do here is we are going to sequentially, you know, first I'm going to toss a coin, first coin, then I will toss second coin, third coin, fourth coin, and n number of coins we can toss, right? So this kind of description of a sample space is going to be known as sequential description. इसको क्या बोलते हैं? sequential description, right? Sequential description. Okay, sequential description is nothing but what? Sequential description. Please keep in mind, sequential description, then another name is there, that is called tree diagram. Tree diagram, okay? Like people call it tree diagram. Okay, you are going to divide your entire problem into stages. Okay, stage 1. Suppose there are 2 coins you have to toss. Okay, so first coin I'm going to toss first, then second coin I'm going to toss. Okay, I hope this makes sense, right? So what you can do here is, suppose you have got this 2 tetrahedral die. So first of all, what we will do, we are going to roll a die, right? So there are 4 outcomes. You can say 1, 2, 3, and 4, right? I hope this makes sense. This is the first stage that I have performed the rolling. Now again we have to roll the die because there are 2 die, right? So this will again give you how many outcomes? 4. Okay, you see. So you can say that this is going to be 1, 2, 3, 4. Why we call it tree here, guys? These are the branches. You see, these are the branches, and this we call it node here. Okay, these are the nodes. So 1, 2, 3, 4, and then you can say 1, 2, 3. Okay, like see. I hope this makes sense. Okay, so if someone is going to ask you, this is 1, 2, 3, 4. Okay, 1, 2, 3, 4. Right? These are the sequential description that people can talk about, right? So it is very simple to understand. Okay, so it is what? Remember, always keep in mind, we don't write 1, 2, 3. We write here 1, 1. This is 1, 1, right? And this is 1, 2. This is 1, 3. This is 1, 4, right? Okay. So already this event like, you know, already 1 you have got in the first roll. So in the second roll, what you're going to get? 1, 1, 1, 2, 1, 3, 1, 4. Next, second one, 2, 1, 2, 2, 2, 3, 2, 4. Then 3, 1, 3, 2, 3, 3, 3, 4. And 4, 1, 4, 2, 4, 3, 4, 4. You will never lose the sight of writing all the outcomes. You will never miss any sort of outcomes. But if you're going to choose this kind of a rectangular box, okay, let's say there are 2 dice, okay, so you can use the rectangular box, right, or a square box, you know, just to showcase all the possible outcomes. But as long as the number of coins or number of you can say number of dice are increasing, so number of outcomes will increase. So you have to always go for tree diagram, and this is my suggestion. Suppose somebody is going to ask you, what is this outcome? Can somebody tell you what is this outcome? So this is going to be 3 and 2. Directly you can say, right? 3 and 2, 3 and 2. You see, this is the third node, you can say, and this is the second branch of the third node, right? Okay, so I hope this makes sense to all, right? You guys can always do like this, hai na? So this is very important to keep in mind. This is called tree diagram. Okay, this is called tree diagram. Please remember, guys. Suppose we have got one coin here. Let me take 1 coin. Okay, and let me roll it. Okay, sorry, let me toss it even, right? I'm going to flip a coin or toss a coin, right? We always flip a coin or toss a coin. So what is going to be a description, sequential description? It is going to be like this. We will get head or tail. Fine. So you can say that the sample space is going to be head or tail. So this tree diagram itself is a sample space. Remember always, this tree diagram itself is a sample space. Next. This is very important to keep in mind, okay? Next is what? Suppose we have got 2 coin, right? So one you have tossed first, okay, head and tail. Again you toss it, head and tail, head and tail you are going to get, right? So in stage 1 you have tossed first coin. In stage 2 you have tossed second coin, or you have flipped, right? So you can collect the sample space here. The sample space is going to be HH, ST, TH and TT. Okay, you see the sequence you are not missing here, right? All the sequence you're going to follow. So if you're going to follow this way of representing the sample space, you can say this is called sequential description. The tree diagram is known as sequential description of the outcomes. Sequential description, right? Okay, so this is nothing but a tree diagram. Okay, so all the outcomes you can say this is nothing but what? So S is going to be equal to HH, ST, TH and TT. Let me take one more example. Suppose you have got 3 coins. Okay, 3 coins you have got. Now how many outcomes will be there in 3 coins? If you're going to toss 3 coins, or you can say if you're going to flip 3 coins, so how many outcomes is going to be in the sample space, right? So I'm not going to write now the sample space in terms of that set or something. I'm going to always give you the sequential description or a tree diagram. That will give you a very intuitive idea, okay, of answering the question very quickly, right? क्या होता है मुझे पता है, across India, anywhere you go, right, whatever teacher is teaching you, they always give you what? In fact, they teach tree diagram also, but they don't talk about what is the need of that. Actually, that, you know, sequential description is going to make your life very simple. अगर कोई भी चीज आपकी लाइफ को ज्यादा सिंपल बनाती है, that you have to always accept it, okay, happily. उसमें कोई डाउट नहीं आना चाहिए, ठीक है? That is very important to keep in mind, guys. ठीक है? So yes, so 3 coins means you know, just toss like this. We take little. Okay, so 1 coin tossed like this, then second coin is tossed like this, then third coin is tossed like this, tossed like this, tossed like this, tossed like this. Okay, so you can count now 1 2 3 4 5 6 7 8. Okay, so you can quickly say that, yeah, 8. Okay, but there is a formula also that I'm going to introduce, right? So this is going to be your head, okay, tail, then again head, tail, head, tail, then again head, tail, right? Only 2 possibilities are there in each call, right? Okay, there are 2 possibilities in each call. No matter how many times you are tossing a coin, you're going to get only head or tail always, right? So now you can write here, this is going to be head, head, head. You take head, 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 tail. Okay, so you're not going to miss anything, guys. I hope this makes sense to all, right? So you can generalize here. Suppose there are n number of coins. Suppose there are n number of coins, right? So suppose 1 coin is there, so 2 outcomes. 2 coins, 4 outcomes. 3 coins, 8 outcomes. So n coins, 2 to the power n outcomes. Okay, in the sample space. Please remember this. Understood? I hope this makes sense to all. Okay. Suppose you have got you know, one dais, you know, one dais is there, right? You can say that pair die. Okay, you can say 6-sided. If nothing is mentioned, you have to consider always the standard die, right? So you can say that what? There will be 6 outcomes. 1 2 3 4 5 6. 1 2 3 4 5 6, right? Again there will be 6, right? So it will be very cumbersome. Okay, so what you can do here is I will tell you the trick. Okay, always remember. Understood? Suppose there are 6 outcome, one die has 6 outcome, 2 36, right, and so on. So n dies 6 to the power n. Okay, 6 to the power n. Okay, so as number of dies increases, the number of outcomes is going to increase. I hope this makes sense to all. How many of you understood this entire story? Yes. So I hope this makes sense to all. What is the meaning of sample space? Okay. How many of you understood this sample space? So how we represent, see, suppose this is a sample space S, sometimes we denote by omega also. So somebody is going to ask you how many number of elements are there in the sample space. So number of element is nothing but number of outcomes. Okay, number of outcomes in sample space. Okay, number of element, we call it number of element. Okay, so if we are going to toss two coin, right? So there will be two outcomes in, there will be sequential description, but first toss head, second toss tail. So that will be a single element. Remember, that is going to be single element. Don't consider separate element. Okay, suppose you are going to toss two times, two coins, right? So first toss head, second toss head. So this is a single element, single outcome, you can say head head, okay, or tail tail, or head tail, tail head, right? So always remember that inside the set that is going to be a single okay. So better what you can do is you guys can go for sequential description. That is my suggestion. Any question you can do then. So it will be very difficult to write. Okay, fine. So I think this is clear for all. How many of you understood this? Now we will talk about what? We will talk about the continuous sample space. This is important. Continuous sample space. This is very, very important, guys. Continuous sample space. Okay? Continuous sample space is one of the very important topic. Okay? So what is this continuous sample space? Suppose I say that, if I say that, let me give you the very good example. In fact, the real time example. Suppose I ask you that, how many emails in a day you receive? How many email you receive in a day? How many email you are going to receive in a day? That is kind of an experiment only, right? Receiving email. So email can be, realistic email that somebody is going to send you, okay, in your, you can say in your company, email address, or sometimes what happens in your personal email, you might get some spam emails. Those emails are going toward the spam. Okay, this is happening because of AI only, right? Your some emails are going into the email spam one, right? So filtering is going on at the same time, right? Understood? So if someone is going to ask you number of email in a day, number of email in a day, okay, so yeah guys, so can you tell me how many emails you get in a day? Yes, okay, it should it is not fixed, right? It will be always greater than 0 or it will be 0. You might get you can say that you might not get any email, or you might get email. You don't know how many emails you're going to get, right? Okay, what is going to the outcome here? How outcome is nothing but what? The number of email in a day, right? Number of email in a day is a outcome, right? You can say, okay, and this is going to be a sample space, right? So how you will write the sample space? This is the outcome, you can say the outcome. How can you write the sample space? Sample space should be written in terms of this, okay? So you can say here is that what? This x is going to be, x belongs to integer number, right? So I mean you're going to get 2 email, 3 email, 4 email, right? So this z can be integer here, I mean z, okay? But here one more condition is going to be, this x should be greater than or 0, okay? So number of emails should not be negative also, that you have to remember, right? So what we are going to choose here is, what is the meaning of that? The meaning of this is non-zero integer. Okay. So this is what? This is a continuous sample space, guys. Okay. I think many of you can identify. This is, can somebody name of this set representation? What is the name of this set representation? See, there are two set representation, right? One is called what? If there are elements, right? So one is called the a roster form, one is called the set builder form. So can somebody identify what is this? So if you're writing in this format, okay, you are representing all these description in terms of, you know, deciding some variable here. This x can take value 0 greater than 0, or, you know. So this kind of sample space is known as continuous sample space, right? Here the number of elements are not finite. You can take any number, right? I think this is fine. Okay. So as Deep is saying, this is called set builder form. Yes, very true, right? So if you're going to suppose any element is there and you are going to write that element with the help of some property. Okay, see here x is going to be a number of element in a day, right? But what is the property of that x? That x should be integer, but what kind of integer it should be? It should be positive integer, right? So this is how we use the concept of mathematics, okay, from very basic thing. I'll talk about the basic mathematics which is needed, okay, to understand entire probability theory. Okay. The next example also I can tell you, which is a very real-time example. Okay, so number of email. Why I have given you this example? Because we are talking about, you know, probability theory for machine learning and AI. Okay, so you should always give this kind of example, right? Because many people know like tossing a coin, all those things. But what is the example of continuous sample space? You guys can give these examples. Okay. The second example that I'm going to talk about is how many hours on YouTube you spend in a day, right? So YouTube hours in a day. This is also going to be kind of well-known continuous sample space that we can talk about now after COVID-19. You know, after Geo launched the free subscriptions for 1 year, right? So, you know, everyone started spending the hell amount of time on YouTube, right? Okay, nobody is nowadays having any kind of memory in their mobile phone to have that kind of, you know, earlier we used to take some music from somebody. Okay, can you transfer some songs, right? Understand? But nowadays we are just rely on YouTube, right? We spend most of the 24 hours on just watching random videos, random reels and everything. Yeah, TikToks. So though in India TikTok is banned, but now so many reels, Instagram, so many things. Okay, so how much time you're going to invest here, right? How much time you spend? So YouTube hours in a day. So you can say that in a day, how many hours are there? 24 hours, right? Certainly you are not going to spend 24 hours. I'm very sure, right? So you're going to spend hours between 0 to 24 hours, certainly, right? So you can say that x is going to be a real number, s is the sample space, and I'm going to talk about now x. X says that x says that x, okay, x is what? X is belongs to real number, right? Okay, and this x should lie between 0 to 24. So this is the example of continuous sample space, you can say. Okay, understood, guys? So I hope this makes sense to you. One more example of sample space that people can talk about is, let me give you. Suppose you have been given like this. Suppose x and y is there, right? X and y is there such that x and y can take a value, right? X and y can take a value 0 and 1, between 0 and 1. So this is nothing but what? Continuous sample space. Okay, but these things nobody talks. Okay, these things are directly talked in case of random variable only. But here you have to understand. Okay, before we enter into random variable and all, we need to understand what type of sample space is there. So guys, you can also write what are you learning each day in the comment box, right, after watching the session, right? So that if somebody is gonna visit the channel, they can get the overview also, right? That yeah, you guys have learned something new from this. Okay, good. Fine. So see here, x can take value between 0 and 1, y can also take value between 0 and 1. So how can we plot this? Okay, so as a mathematics student, right, you should be able to plot here. So this is x, this is y. This is x, this is y. In future, I'm going to call this x as x is a random variable, and this small x is going to be a value taken by the random variable. So right now, I'm not talking about random variable, guys, because I did not talk about probability anything. तो अभी मुझे बात नहीं करना है. I just I'm highlighting these things. The continuous sample space will be very useful. Then we will deal with the random variable. Fine. So this x can take the value between 0 and 1. So this can take any value. Here, values are not finite here, right? And this y can take again. So this is going to be the space here. This is the sample space, you can say, right? This entire, okay? This is the sample space. Now, suppose this is a kind of, suppose this is your target, right? And there is a target in the center, right? Or you can say this is the target in the center. Someone is going to ask you, can you shoot? And what is the probability that you're going to shoot this, right? The target. Okay, understood. That is very important to keep in mind. So exactly you can't decide. Okay, exactly it is not possible that you can say that, yeah, certainly that is going to hit the target only in the center, right? What we can say that, suppose if suppose you are shooting here, suppose your arrow, like suppose your gun shot is here, right? Some shooting in this area, okay? So some probability is going to be shooting in this area, some probability. So we can find out the probability here, right? Okay, we can find out the probability. So this is very important to keep in mind, right? So we can divide this sample space into different parts, okay? In fact, sample space, we can talk about the subset of the sample space, right? Understood. Suppose you got you got 6 outcome, okay? You rolled a die, you got 6 outcome, right? But those 6 outcome has got some different properties, right? Like 1 is odd, 3 is odd, 5 is odd, right? So they might ask you how many odd outcomes you got, okay? How many even outcomes you got, how many prime numbers you got, right? So these are the subset of the sample space. I think you guys can recall what is the meaning of subset of the sample space, right? The subset of the sample space is going to be called as event, okay, of the random experiment. Okay, I hope this makes sense. And the word probability, okay, is basically assigned to an event. We always compute the probability of an event, guys. We don't talk about the probability of the sample space. We always talk about the probability of event inside the sample space. Okay. So first of all, we will decide what is the sample space, and within that sample space, something has to happen, right? That belief I'm going to compute with the help of probability. I think now you understood what is probability basically. Okay. Probability is nothing but we always assign probability to the event, and that event is going to be the subset of the set. मतलब एक सेट रहेगा, उसके अंदर जो चीजें होंगी उसी की हम प्रोबेबिलिटी फाइंड करेंगे. बाहर क्या हो रहा है मुझसे मतलब नहीं है. Fine. That you have to remember. So these are the sample space. Please remember this. Okay, I hope this makes sense to all. Everyone understood this, yeah? So what is, guys, what is the event here? Let me define the event as well. The event is nothing but what? Event is nothing but it is a subset of a sample space. Okay. Subset of sample space. So there are various way of representing. Suppose you can say that getting an odd outcome in throwing dice. Getting an odd outcomes in throwing a dice. Okay, so what is the sample space here, guys? Sample space is going to be 1, 2, 3, 4, 5, 6. Number of elements are 6. And what is going to be the event here? Event we can denote with the help of capital A, right? So odd outcomes only you have to take. So 1, 3, 5. 1, 3, 5. So this is called event. And now we can assign the initial belief to this event, right? That is called probability. So probability is always assigned to an event. This is very important example that I'm telling you guys. Okay. So other event also you can define here, right? One event is this, another event you can say is C, okay, or B you can say, right? 2, 4, 6, like, you know, getting even outcome, okay, and C also you can define like getting prime numbers, so 2, 3 and 5, okay, 2, 3 and 5, understood? So you can decide in a sample space there can be many events, right? Many events, and there are various properties of event also. There are various properties of event. Okay, so that is very important to keep in mind. I think this is clear. Yes, guys. Any doubt till this point before I wind up the session? Because today I talked about the basic thing, and today is the first session, so I'm not going to invest much time here, right? Okay, this is very important to keep in mind. Okay, so remember, always remember, I'll talk about probability axioms now, right? Probability axioms. Okay, this is very important axioms, right? Probability axioms. Okay, and what is this probability? Always remember, under these probability axioms, first of all, we will talk about event. So as I said, that event is nothing but what? The subset of a sample space. Subset of sample space. Okay. So I will cover the prerequisite, the math behind the probability. Don't worry. If you guys are not comfortable with set, Venn diagrams and all, so I will be covering. That will take only 1 hour to complete everything. In fact, not 1 hour, 20 minutes only. Right. So suppose this is called, this is the sample space, you can say S, or you can say omega or S. Right? Understood? I think this is clear, right? And you can say that this is going to be an event A. The discrete sample space, you can say. And if you take the continuous sample space 0 to 1 and 0 to 1, so you can say that this is the, if suppose your bullet is going to fall in this half, okay, so this is the event, you can say, right? This is going to be subset of the event. Okay, understood? So we are going to find the probability of that bullet to hit that area, so see, the word area is coming here, area. Okay, area, right? Keep in mind, this area is also very important. It has very profound relation with the probability, guys. Okay, remember. So when the sample space will be continuous sample space, the probability will be considered as area concept, right? Remember, area. I will say probability is nothing but area. Now whether you accept or not, I don't care, right? ठीक है, याद रखना. तो अभी हम बात नहीं करेंगे, ये continuous का example है. This is, suppose this is one event and this is one event, right? Like in this area, if bullet is going to fall. So always remember, the probability is assigned to an event. Probability is assigned to an event. I think this is clear. Suppose A is the event here. So how we will write probability? We will say that probability of A. And probability of A means this is called initial belief. Okay, that event has to occur. What is probability, guys? Something that has to happen. जैसे आपका, you are preparing for the gate examination and you can decide one event कि अच्छा, I'm going to get success, right? Okay. Your preparation is going to be a sample space, and the success is a part of preparation, right? You can subset, right? So that is your initial belief that you're going to get success in the gate. You're going to get into ISC or IIT Bombay, right? Or IIT Madras, whatever. So you have to first of all decide the initial belief. अगर belief ही नहीं है कि ये होने वाला है, तो कुछ नहीं होगा फिर जिंदगी में, right? अगर belief नहीं है कि धीरज सर पढ़ा रहे हैं, क्या पढ़ा रहे हैं, अच्छा पढ़ा रहे हैं कि नहीं, कुछ लोगों के माइंड में ऐसा रहता है, सीन इन द मार्केट, राइट। तो उनको ये नहीं पता है कि यार गलती से भी अगर लेक्चर देख लिए, गलती से प्रोबेबिलिटी एंड स्टैटिस्टिक्स, लीनियर अलजेब्रा, मैथ या कि कोई भी सब्जेक्ट का लेक्चर मेरा अगर देख लिए तो लाइफ सेट हो जाएगी गलती से, ठीक है। Okay, so that is kind of random experiment is going on, right? By mistake, if you happen to visit this YouTube channel and you watch these sessions, so these sessions are the amalgamation of various standard resources, okay, which are available online, okay. So content which I'm giving you is really unique and everything is new. I think this is clear. Yeah. So remember always, this is going to be an initial belief, okay, that event has to occur. Okay. So in future, I will talk about, like in the next session, what is this probability axioms, right? And so on and so forth. Yeah. So guys, now it's time for doubt. If you have any doubt, then ask. Otherwise, we'll wind up the session. Yeah. And how was the session you have to write today, so that I will get to know that yes, things are going well, and we can bring another session. And we have to finish this probability story within 10 days. So आपको प्योर शॉर्ट फुल मार्क्स आने वाले हैं, लाइफ में कभी भी नहीं भूलोगे प्रोबेबिलिटी। या yes, anybody has doubt? Pooja, Atif and Deep and other people? Okay, thank you so much. We'll meet in the next session. Take care, keep learning, okay?